In this video, we're going to pick up where we left off from the previous video, and we're going to talk about how we structure the null and alternative hypothesis for analysis of variance. And we'll actually do an ANOVA test with the data from these two cases that we saw in the previous video. And we already kind of know the conclusion that we're going to come up with, but I think it'll be kind of nice to see this executed in R. So let's look at the hypothesis for ANOVA first. I'm going to talk about this in a general sense, and in a future video we'll do one with a particular example. Because ANOVA, it's a generalization of a two-sample t-test, we have our null hypothesis look very similar to that of a t-test. In a t-test, we would just have two groups, right? And the null hypothesis says that the mean of the two groups is the same, the population mean. But in ANOVA, you would keep on rolling. You would have your third group mean indicated, and if you had another group, then you would just let the good times roll, and you would indicate the mean for the fourth group and the mean for the fifth group. And if you had more, you just keep on going till the end. But here, since we're only going to stick to 3 for this example, I'm just going to leave it at 3. In the alternative hypothesis, when we have a regular two-sample t-test, we usually are testing for a difference. And sometimes we want to be more specific. If you have reason to use a directional alternative hypothesis, that's okay. But with ANOVA, it's a little different. Because you've got 3 groups, 4 groups, many groups, it doesn't quite work to do it in this sort of t-test way. So we say, in ANOVA, the alternative hypothesis, at least one of the population means is different among the groups. Again, I'm being quite general here. With context, you want to be specific about it's the population mean what? You know, I like my fish. Maybe you're talking about the mean length, and you're comparing it across the different species, right? You do want to specify that. And here you wouldn't just write group 1, group 2, group 3. You might actually write that this is the cutthroat species, and this is rainbow. And maybe over here you've got brook trout. Or for another example, maybe you're comparing the weight that was gained or lost across different diets. And you would label your groups, I don't know, diet A, diet B, diet C, right? You want to be specific. And in each of these little quickie scenarios, what I've got here that I'm circling, that's the response variable, right? That's what was of interest in the study. And then here are the categorizations. That would be the explanatory. So let's move into looking at R, and we're going to look at these two cases. Okay, so I've got R open here, and let's take a look at the data that I have created. I've got case 1 sort of on the left side. This is all within the same data frame. And here I've got the values, so that's the response variable measured. And the groups are indicating treatment 1, treatment 2, treatment 3. And we see that there are 5 values in each treatment. And then I've got the case 2 values over here organized in a similar way. Let's start with case 2, because that was the last group that we saw, right? We saw that these values, certainly the treatments are different from each other, but they are not overwhelmingly, they are not significantly different. I'm going to anticipate a pretty big p-value from this second case. Let me show you how to type that into R. So the code is analysis of variance. And I'll do a note here first. We want to do y, the response variable, squiggle x. Okay? And I like to give this a name. So I'm going to say name, okay? And then the next step is to get a summary of that name. And that's what we're going to do here. So let's do, I'll call it case 1, case 2. Case 2 equals analysis of variance. The response variable, those are the values. Case 2 values. And that's in the data frame EX. And I need to do squiggle the explanatory variable, which is the vector case 2 groups. Okay. Now that I've done analysis of variance, right, no news is good news, I'm going to ask R to give me a summary of case 2. And there's a lot of info here, and we're going to dissect this. This is what's called the ANOVA table. ANOVA table. And there's a lot of elements in here. We're going to focus on a couple of them. Over here on the right is our p-value. This is the probability in the tail larger than in the F distribution. So that is the probability of obtaining a test statistic like we have, or something more extreme. And as expected, we got a large p-value indicating that we do not reject the null hypothesis. This p-value is a result of this test statistic. This is the F test statistic. And we're not going to calculate it, but it's based on certain sums of squares. We've talked about sums of squares in the past. So there's kind of a lot of calculations that go into it. But something else that I want to discuss in this ANOVA table is this first column, degrees of freedom. There are degrees of freedom associated with the two sources of variability here. This first row is quantifying the amount of variability between the groups. There were 3 groups, so this is degrees of freedom 3 minus 1. Here, the second row, R calls it the residuals. Some books will call it error or the within group variability, but this is the degrees of freedom for the number of observations. Now you might remember that if you look at this, there are 15 observations. If you totaled that degrees of freedom up, wouldn't you get a 14? Therefore, n minus 1 is 14, which tells you that n was 15. Anyways, I just think that's a really neat little aspect that isn't too computationally intense, so we might as well go over it. At the end of the day, for us, I want us to know how to write these hypotheses and be able to read this ANOVA table and be able to do ANOVA in R and read this ANOVA table. Let's do the other case here. Let's do the other case. Right, this was the first case, which contains values that their samples are super different, right? We're going to redo this. We're going to anticipate a rejection of the null hypothesis. Okay. I'm going to call this, I'm going to be a little lazy. I'm going to call this case 1, and I get to just change these. And now I'm going to do a summary of case 1. We're going to get this ANOVA table just like a second ago. And we're going to look at that p-value. And that p-value, we're expecting it to be very small. Look at that. Ah, yes. Take that 2 and move that decimal to the left 16 times. That's a small, small number. So as expected, we are rejecting the null hypothesis because the p-value is less than alpha. Now, we didn't even mention what alpha was. It's usually 0.05, right? That's going to conclude this video. We got a lot in here. We saw how to structure the hypotheses in ANOVA. It's pretty similar to a t-test, but there are a couple distinct differences. And we also saw a couple quickie examples in R. But in the next video, we'll do a full-blown example with a particular scenario so it's not so generic. See you there.